Hello everyone, this is Lenu. Welcome to LearnWise. Hope you guys are doing well. In today's video, I'm going to discuss about the topic Chemical Kinetics, a very important topic of grade 12 chemistry. Okay, hope you have watched the last video of coordination compounds and equilibrium. I hope you enjoyed the video. If you found it useful, please like our channel, subscribe it, and click the bell icon. Okay. Now let us move on to chemical kinetics today. So, what is chemical kinetics? Yes, of course it's a branch of chemistry, right? It is dealing with reaction rate. Okay, rate of particular reaction. Imagine you are going to cook an egg. Okay, have you ever noticed how the texture and color of an egg change when it is cooked? It's a great example of chemical reaction, right? And another example is rusting of iron. Okay, you have seen iron nails rusted or a car with rust spots, right? So how this happens? This is due to its chemical reaction. Iron is reacting with air, moisture, etc., forming rust. Okay, then we have seen the food gets spoiled due to chemical reaction, right? For example, when we cut some apple, after some time, we can see it will turn brown in color, right? All these are examples in our daily life, okay, from the topic of chemical reaction. So we are going to discuss here how fast the reaction is, that is chemical kinetics, okay. Yes. So let us discuss in detail. And chemical kinetics means, that is, it is dealing with rate of the reaction, its factors affecting the rate, that all things. Okay. So here the main points we are going to discuss in this topic. First of all, rate of a reaction. Rate of a chemical reaction. We have to find an equation to calculate the rate of chemical reaction. Okay. After that, we will be discussing about a rate constant. Then we have to find out the order and molecularity of the reaction. That is very important. Order and molecularity. And we have to reach a rate law expression. Okay. After that, we will be discussing about integrated rate equations of first order, zero order, second order reaction. Okay, integrated rate equations. Zero order and first order we will be discussing in detail. Half-life. Next, we have to deal with half-life. Okay, half-life. After that, we have to deal with the pseudo first order reaction. Pseudo first order reaction. And at last, we have to deal with factors influencing the reaction. Factors influencing. Last is very important, Arrhenius equation. Okay, so these are the topics, subtopics we are going to deal in this topic, chemical kinetics. Okay, very clearly with examples, questions, previous years, everything we will discuss. Okay, let us start. Okay, firstly, we are going to start with rate of chemical reaction. So, as I told you, rate of a chemical reaction means the speed in which the reaction takes place. Okay, let us discuss with an example. Reaction between A plus B giving C plus D. Okay, this is a certain particular reaction, and these are the reactants, and C and D are the what? Products. Okay, so we can express the rate. We can express the rate in terms of, okay, in terms of reactants or products. Actually, when the reaction starts, reactants start decreasing, right? So rate is expressed. We are expressing it in terms of decrease. Decrease in the concentration. concentration of reactants. Okay, that means reactants are decreasing. Any of the reactants. Okay, concentration of any of the reactants, A or B, anything you can write, or you can express it in terms of what? Increase in the concentration of any of the products. Increase in concentration of any of the product. Okay, any of the product. Yeah, like that, any of the reactants. So let us equate it. Rate. Rate means what? Rate means decrease in concentration of any of the reactants over time, right? Over time. That is, rate is always measured in particular time, in unit time. Okay, unit time. You have to divide it with time. So let us discuss the equation for rate in terms of this rate is equal to. So concentration of the reactants are decreasing. So we have to put a negative. Okay, right. Then what is happening? Reactants A and B are the reactants, right? Concentration of A over time delta T we are taking. Okay, delta T, yeah, D by dt. You can take anything. Okay, delta change. And also you can write in terms of B also, B by delta T, or right is also equal to concentration of product increase. So no need of writing what? No need of writing negative sign. The C by T, it is also equal to D by T. So many equations you will get as well. Any of the concentration, either it is reactants or product. If it is reactant, you have to show a negative sign to understand it is a decreasing. Okay, let us consider one example. You will be getting clear. Okay, for example, N2 plus 3H2, 3 hydrogen in, sorry, not equilibrium. It is reacting. It's an equilibrium reaction. Okay, so it is reacting to form 2NH3. Okay, how will you write down the rate formula? So rate is equal to minus delta concentration of N2 over delta T. That is equal to, okay, hydrogen, right? Minus, it is also reactant, so you have to put a minus. Here 3 moles of hydrogen, right? You have to divide that 1 by 3. Delta concentration of hydrogen by delta T. Okay, and it is also equal to, let us write in terms of products, 1 by 2 delta concentration of NH3 over delta. Either in terms of reactants or products, you can write down the rate formula. Hope you understood. Okay, this is rate of disappearance of nitrogen, and this is rate of disappearance of hydrogen, and this is rate of appearance of ammonia. That is the thing we understand from this equation. Hope you get it, right? Next, moving to classification of rate. There are two types of rate. We can say average rate as well as instantaneous rate. Both are rate, average rate as well as instantaneous rate. What is average rate of the reaction, or what is instantaneous rate of the reaction? Okay, so rate is, we know that rate obtained by dividing the change in concentration of component by 10 is the average rate. Okay, that is, we have to, this rate is obtained by change in concentration over time. That is what average rate. Okay, that is concentration is changing over time. Okay, so the rate does not remain constant. It is called as average rate. Then what is instantaneous rate? It is at a particular instant of time. Particular instant of time. That is instantaneous rate. Okay, that is the difference between average rate and instantaneous rate. And next is very important point, unit of rate. It is always constant. We know the equation, rate is equal to concentration by time, right? And concentration is always measured in what? Mole per liter. Over time is measured in mainly seconds, yeah, minute, etc. So the rate is always concentration, time is in denominator. So I'm taking to the upper side. Concentration times time raised to -1. That is mole. Liter is also on the denominator, right? Mole raised to 1, liter raised to -1, S raised to -1. This is the unit of rate. It is always same. If you are expressing gaseous component, instead of concentration, you have to write like a atmosphere second. We have studied this in the equilibrium topic, right? This is the unit of rate. This is always constant, no change. But when we study about rate constant, it will change. So you have to consider that. Okay. Yes. Now let us consider an equation and problem. Okay. So a simple problem I'm going to write here. For a rate N2 plus 3H2 gives 2NH3, it is given the rate of formation of ammonia is 4 times 10 to the power -8 mole. Since it is a rate, we know the equation, unit of mole, right? This is mole. Okay. And you are asked to find the rate of disappearance of hydrogen. Okay, so this is the question. You are given an equation and rate of formation of ammonia is given. So you know the equation. So the equation ammonia formation and hydrogen. So that only we need. Okay, so just write down rate formula. Rate is equal to -1/3 d by dt of hydrogen, which is equal to 1/2 d by dt of ammonia. And it is given what? D by dt of ammonia is given, right? Yes, 4 times 10 to the power -8. We are asked to find what? Rate of disappearance of this hydrogen. That is minus d by dt of hydrogen. You have to find. So you have to take this 3 to this side. So you'll be getting 3/2 times rate of d by dt of ammonia is given this. So 4 times 10 to the power -8. So you'll be getting 6, 2 and 4 cancel each other and 2 times. So 3 times 2, 6 times 10 to the power -8. And what is the unit? You have to mention the unit. Mole. Liter raised to -1, S raised to -1. So this is the method we are doing the problems. Hope you clear, right? Yes. Now moving to rate law or rate equation. Rate law, or you can call it a rate equation. Yes. So let us consider a general reaction. What is a general reaction? A plus B gives C plus D. This is a general reaction. And according to rate law, reaction rate depends on concentration of the reactants. Okay, we have studied this in the equilibrium, right? Rate, according to law of mass action, rate is equal to, okay, rate is proportional to concentration of the reactant raised to, okay, that's stoichiometric coefficient, and B raised to B, that is rate is equal to K. In order to make it equal, we have to remove that proportionality by putting a constant A raised to A, B raised to B. Okay, so this is the rate equation. And next we have to understand the characteristics of rate constant. This is useful for you guys in both chapters of equilibrium as well as kinetics. Okay, characteristics of rate constant. Very important. Rate constant characters we are going to discuss. And whether it is what rate constant is depending on whether the reaction at the particular time, not at the initial concentration. So we are not considering the independent. So this is independent of what? Initial concentration. Initial concentration, okay, of reactants. That is, it is not affected by the change in concentration of the reactant, okay. And it depends on what? Depends on temperature. The temperature changes, rate constant changes, okay. Depends on temperature. And equation is the next point. Rate is equal to rate constant times concentration of reactants at that time, okay. Concentration of reactants at that time, okay. And next important point is presence of the catalyst. Okay, if we add catalyst, what will happen? It will lower the activation energy. It changes the activation energy, hence the rate of the reaction changes. Reaction rate changes means what? Rate constant also changes. Catalyst changes what? Changes a rate of reaction. So rate constant also change. And the last point is unit of K depends on order. So we are studied about the unit of rate, right? Like that, you will be going to study unit of rate constant K. That depends on what? Order of reaction. We are going to discuss about order, don't worry, okay. So these are the characteristics. That is, it is independent of the initial concentration of the reactants. It depends on temperature, okay. And rate is equal to rate constant times concentration of the reactants, and catalyst affects the rate, and unit of rate constant is equal to order of the reaction. Now we are going to discuss about order of a reaction. Order of a reaction. Let us write down the formula for rate is equal to K times concentration of A raised to X, B raised to Y. So in the rate equation, we have written like this can or cannot be, we can write here like X and Y, okay, because it may or may not be equal to A and B. It is not like it must be equal to A and B. That is not a case, okay. It can or cannot be equal, okay. We have to do like that. Can or cannot be equal to this A and B, okay. It is raised to some sociometric coefficient, okay, right. So that is the thing. No, we cannot write it at A and B always, okay. So x and y. So order of the reaction is just simple. Order is equal to, you have to take the sum of that coefficient. Take the sum of the powers of concentration of the reactants in the rate law. That is order of the reaction. So this order can be a whole number. It can be 0. It can be any fractional value. That is the main properties of what? This order of the reaction. And order of the reaction can be determined experimentally. It can be determined experimentally. Now moving to the next important topic of unit of rate constant. Unit of rate constant. Don't confuse about rate and rate constant. Rate constant is K. How will you find the unit? So we know the equation K is equal to a rate over concentration of A raised to X, concentration of B raised to Y, right? And what is the unit of rate? We know mole, liter raised to -1, S raised to -1. And what is this? This is also concentration, right? Some concentration raised to some number. What is the number? Equal to X plus Y. That is the order, right? So concentration raised to this order. That is N is equal to X plus Y. That is the order of the reaction. So how will you make this? This is also concentration. This is also concentration. So concentration means we can write like this: s raised to minus 1 by mole raised to minus 1 raised to n. So we can equate it as mole liter raised to minus 1, that is 1 minus n s raised to minus 1. So this is the general expression for the unit of rate constant. This is the general expression for the unit of rate constant. If you by heart, I think no need of by heart in this. If you can by heart this, it will be easy. If you are confusion, if you feel any confusion during the exam, the general equation, you can easily dictate this from this. You know this equation, K is equal to rate by concentration, right? Rate we know. Rate unit you already know. Concentration raised to n. So you can easily find it is mole liter raised to minus 1, 1 minus n. N is the order, s raised to minus. So using this equation, you can easily write down the zero order, first order, second order rate. Okay. So let us find out zero, first, second, and third order. Okay. Unit of rate constant. We are going to, for zero order, n equal to 0, right? N equal to 0. So what will be the expression? Mole liter raised to minus 1, n 1 minus n equal to 0 means what? It is 1. 1 means no need of writing that. So s raised to minus 1. So what do you understand from this? What unit is this here? This is same as what? This is same as the rate unit, right? S raised to minus 1. So you can write like it is same as rate unit. Okay, very important. Which order will be same as the unit of rate constant as and rate? So you have to write down 0 order. Next is first. First means what? N minus 1 minus 1, that is 0. So that term will become 0 and you will be getting the unit as only S inverse, S raised to minus 1, time raised to minus 1. And for second order, mole liter raised to minus 1, 1 minus 2, S raised to minus 1. So we'll be getting what? Mole minus 1 liter, that is positive now, S raised to minus 1. And for third order, you have to find the third order unit using this general expression and comment it in the comment box. Let me check you are getting how to find out the unit of rate constant. Yes. Okay, moving to the question. It is given that equation is given 2NO2 minus plus 4H plus 2I minus gives I2 plus 2NO plus 2H2O. And it is given the rate is equal to K NO2 minus H plus 2 and I minus. This is the rate law given. Now, the question, there are 3 questions. We will be discussing the questions one by one. The first question is, imagine all the concentration we are going to double. Okay. All the concentrations we are going to double. Okay. What will happen to the rate constant? What will happen to, happen to rate. Okay, happen to rate. So this is the rate law equation, expression is given. So I'm going to double all the concentration. So we can write rate is equal to K into, this is also double, so it will become 2NO2 minus, right? If you double this, what will happen? It is also double means 2H plus square is there and 2I minus. Taking the numbers out, you will be getting 2 times 2 square, 4 times 2. That is how much? 16 times. So the rate is if you double all the reactant concentration, rate will double, not double, rate will increase by 16 times. Hope you get it. This is the method we are doing. Okay. So, yeah, one more question we will do. One next question. If the concentration of NO2 minus and H plus are doubling. Okay, H plus are doubling. And nothing is happening to I minus. So what will happen? So rate is equal to, what is rate? Rate constant times NO2 minus, it is doubled, and H plus is also doubled, right? And nothing is happened to I minus. So what will happen? 2 times 2 square 4. Then remaining things. Okay. So what will happen to the new rate? Rate is increased by how many times? Yes, it is increased by 8 times. So this is the method you have to follow. Okay. Now moving to molecularity of the reaction. Molecularity of the reaction. So order, we understand that it is just the sum of the powers of the concentration terms, right? Here, what you have to do is, molecularity of the reaction is the number of reacting species. Number of reacting species that undergo simultaneous collision to produce a chemical change. This molecularity is just a theoretical concept, okay? Is just a theoretical, it is not experimentally verified, it is just a theoretical concept, and it can have only the whole numbers, cannot be zero, cannot be fractions, etc. Only be whole number. Let us do some questions with examples for molecularity. NH4NO2 giving N2 plus 2H2. What is the molecularity here? 1, right? So molecularity is 1. Another example, 2HI giving H2 plus I2. What is the molecularity? It is 2. 2NO plus O2 giving 2NO2. You'll be getting molecularity as 3. So this is the method we are finding the molecularity of the reaction. Hope you understood. And you have to understand the difference between molecularity and order. I already said order is just experimentally verified. Okay. But molecularity is not. It's just a theoretical concept. Okay. You have to know that. And order can have what? Whole number, zero, fractions, etc. Molecularity cannot have zero or fraction, only whole number. And this order, okay, order, just write down order is a, it's experimentally verified. This is only theoretical. And next is order can be zero, fraction, etc. And this is only whole number. And one more thing you have to understand before next difference between order and molecularity is elementary and complex reaction. Elementary and complex reaction. What are elementary reactions? That is the reaction taking place in one step reaction. Okay. And complex reaction just opposite what? There will be various steps. Okay, many steps. Various steps. Okay. So in elementary reaction, it is very simple. There is no other step, just one step, right? So how will you find the order? That simple step. You can easily find that. That molecularity is also get from that. But in the case of complex reaction, we have to take the slowest step. That is the rate determining step. Rate determining step. So how will you write the difference between elementary and complex reactions in terms of order and molecularity? Order is applicable, okay? Order is applicable to what? Elementary as well as complex reaction. Okay, elementary as well as complex reaction. Okay, while molecularity is dealing with what? Only elementary. Because when there comes complex reaction, what will happen? Only elementary. Okay, only it is dealing with only elementary reaction. Okay, hope you understand.